Okay, so today we're going to finish our motion unit. We're going to have a worksheet on position. We're also going to talk about distance from the origin and displacement. Okay, and then Tuesday we'll have an AP day where we will do some free response in class, multiple choice homework, and then our test will be Thursday. Okay, this is not a very long unit, but it's a very important unit. Even though it hasn't been as long as other units, it's still going to be full weight in the grade book as a regular 100 word test. Okay, so you decide whether that's good or bad. The quizzes went really well, so I'm hoping that this could be maybe a new grade booster. Okay, so the rate of change of the position is the velocity. The rate of change of the velocity is the acceleration. So, how would I get position if we know velocity? And what would the antiderivative of acceleration be? Velocity. Now, yes.
Just out of curiosity, because you can write the second derivative of something. Can you write the second antiderivative?
No, we don't say that. Now, and the reason for that is because if I'm going to take the antiderivative of something, okay, either I'm going to take the antiderivative and write plus c, or we need some sort of a condition to where we can find what that c value is.
Yeah.
Okay. Derivatives we can just keep going and going and going and going. Antiderivatives we need a little bit of something. Okay. A little more information. So let's look at this example. Okay. Find the position function of a particle with the velocity this, and we know that we're at position 4 when time is 0. So we have a positive position, we're 4 to the right of the origin at time 0. So if I want the position function, first we need to take the antiderivative of velocity. Okay, well, whoa. We know that our velocity function is cosine of. Okay. What is the antiderivative of cosine? Anything else I need to worry about? Okay, we have to do backwards chain rule here. 1 over pi plus c. Now, we know that what our position is at time of 0. Okay, so if we plug 0 in for time, our position should be 4. What's the sign of 0?
0.
So our c is 4, which means that our position function is given by 1 over pi sine of pi t plus 4. Now, what if we know our acceleration function? How would we be able to get to our position? Okay, we would need to do the antiderivative twice. What else would we need?
C.
Okay, we would need to know something about the velocity at some point, and we would need to know something about the position at some point, right? Okay, so here we go. We want the position function if we know the acceleration and our position at time 3 is 8, our velocity at time 3 is 2. Now, in this instance, we know two things about time 3. These wouldn't necessarily have to both have matching t-coordinates, okay? But in this case it does. So first of all, if we have acceleration, then we can take the antiderivative to get to velocity. Okay? So we're going to take the antiderivative of 3t squared plus 2t. Antiderivative of 3t squared plus antiderivative of 2t. And then we're going to put our plus c. So there's our general velocity function. But we know that at time is 3, our velocity is 2. So when we plug 3 in for t, then our velocity should be 2. Let's go ahead and help me out there. What does that make c? Negative 34? Double check, Aaron. Okay. So our velocity is t cubed plus t squared minus 34. Now let's talk about our position. Okay. In order to get our position, we're going to have to take the antiderivative of the velocity. Okay. So antiderivative of t cubed, great, t squared, and then minus 34t plus c. And we know at position, our position is 8 when time is 3. So if we go back in here and we plug in 3, then our position should be 8. Yep. Where does that make C? Question?
Yeah, the second to last blue one was
Uh-huh.
with negative 31.
34. I think it's going to be a fraction. What'd you get? Anyone else? So our position questions? Alright. Let's talk about displacement. What do I mean when I say displacement? how far away are you from the origin, right? Okay. So, displacement is the resulting position of a particle after a certain time period. Okay. So, I would not say absolute value, because we want to know how far we are in which direction. Right, am I 5 to the right or 5 to the left of the origin? Okay. So, like I said, negative displacement means we're going to be on the left side, right? If we get a negative position, we're to the left. A positive displacement means we've ended up on the right side, right? And displacement of 0 means it returned back to the origin or original position. Now, how can I find displacement if we know something about its velocity?
You can find
What?
Okay.
So,
velocity.
take this for instance. Say I know my velocity equation. How am I going to get my displacement? Okay, let's think about this. If I had velocity, how would I get position?
Antiderivative.
Okay, antiderivative, or taking the integral. Okay, so if I have the velocity function, okay, we can take the integral to figure out our displacement. Okay, so if I give you an interval, okay, I give you, this is the velocity function. Where is the displacement after this many seconds? Okay, we can take a definite integral with that interval, okay, and figure out where are we in the end. Okay, keep in mind, if you are taking, like if you have a picture, remember that below the x-axis is negative area. Okay, that'll be important in a little bit. Okay, so here's an example of something we might see. Given the velocity, find the displacement after a time interval. So we have velocity in meters per second. I want to know the displacement over the time period from 0 to 3. Okay, so what we're going to do is we're going to say the integral from 0 to 3 of our velocity, and this is going to give us our displacement. How far are we from the origin after these 3 seconds? So, antiderivative of t squared minus evaluated from 0 to 3. So we have 1/3 times 3 cubed minus 3 squared minus 0, right? Which is 0.
Yes.
Okay, so what happened? Okay. We end at the origin. Okay. Or go you could also say we end at the original position, right? Okay. Read this. A particle could move 100 meters, then return 100 meters to the original spot and have displacement of 0. But the distance would not be 0. What would the distance be?
200 meters.
Okay. So, how, if we know something about its velocity, we can figure out what its displacement is by taking the integral, right? How about distance traveled? Okay. Okay. Our negative position, it doesn't matter if we're to the left or to the right of our origin, correct? Okay, all that matters is how far we've traveled. So, to find the total distance, we would integrate the absolute value of velocity. Okay, sign does not matter. Yes.
So you would absolute value the velocity, then put it into the integral? Or would you take
We would have to break it apart. Okay, we would have to integrate,
each section of the column?
yes, and we'll do an example, okay? Displacement, okay, we were talking about net sign area, so, those areas are gonna cancel out. When we talk about the absolute value, we move everything above the x-axis, and so then we can add everything together. Now, when we actually find the integral of the absolute value, okay, we need to figure out where the velocity is negative. Okay, wherever the velocity is positive, we can integrate just fine. But wherever the velocity is negative, okay, we're gonna have to break apart into chunks of integrals. That way we know which signs to change. Okay. So when we're talking about total distance, the first thing you have to figure out, how am I going to determine where I have negative versus positive velocity? Sign chart. Okay. And that sign chart is going to be broken apart by what? Okay, where's our velocity 0? That's going to determine our sign chart, so we can figure out where we have positive, negative velocity, and then we can break apart our integral. Alright? So, same problem. Okay, we've already talked about how our displacement was 0. We ended in the same place that we started. Okay. Going back to here, if our displacement is 0, I don't want you to say origin, I want you to say original position. Okay, because it's possible for us to start 5 units to the right and end up back there. Okay? Okay. So now we're talking about the total distance. So here's our velocity. We need to know where our velocity is 0. So I'm going to go ahead and factor this. Where's our velocity 0?
2 and 0.
Okay. At 0 and 2. In between 0 and 2, do we have positive or negative velocity?
Negative.
In between, well, after 2, we have
Positive.
positive. Okay. Now, we want, okay, so our distance is going to be the integral from 0 to 3 of the absolute value of our velocity. Now, what we're going to do is we're going to have 2 integrals since we have one place where our velocity, technically, I mean, yes, we start at 0 velocity, but this 2 is breaking it up into 2 different sections, right? So, first we're going to have the integral from 0 to 2 of our velocity. Now, is this going to give us positive or negative? Is this going to be positive or negative? This was negative velocity, so what we're going to do is we're going to put a negative in front of it so that it becomes positive. Okay, and then we'll add the integral from 2 to 3. Okay, so now we already know what these integrate to, right? This is going to be negative the quantity of 1/3 t cubed minus t squared from 0 to 2, and this is going to be 1/3 t cubed minus t squared from 2 to 3. Okay. So now if we go ahead and we plug these values in, okay, this becomes 1/3 2 cubed minus 2 squared and minus 0. Okay. And this would be 1/3 3 cubed minus 3 squared, and we'd have to subtract. Okay. Now, if you notice, if this negative wasn't here, these numbers where I plug t as 2 in would cancel, right? Okay, but since negative is here, this is making that that negative area positive. Okay, so what do we have here? Can anybody play the same thing? Anybody? What? 8/3? Okay. We had a displacement of 0. We started with and came back, right? But we traveled 8/3 meters. Now I am going to change my mind. Sorry. It's okay to say at the origin for that other problem, the one we did with this. It's fine to say we ended at the origin. Original position at the origin. I'll take either one. Okay. So origin is easier to think about, so let's just call it the origin. Okay. Okay. Questions on this example? All right. Now we're going to throw them together. All right. I have the position. Find, actually, here's the position. I want displacement and total distance over the time interval. How are we going to do that?
If you derive first.
We have to derive. Okay. What do you think?
So you have to
Because we need to know when our velocity is 0,
yeah.
right? Okay. So what is our velocity function?
2 negative sine.
Okay. So our velocity is -2 sine of t. Okay. Between 0 and 3 pi over 2, when is that 0?
0 for 1.
Okay.
And yeah.
And when?
Yeah.
0 and pi. Right? Between 0 and pi, do we have positive or negative velocity?
Oh, negative, yeah, negative is right. Yeah.
Between pi and 3 pi over 2, we would have negative velocity, correct? Okay, so our displacement. From 0 to 3 pi over 2. What's our displacement? So, antiderivative of -2 sine of t. We already know it. Because of this function right here, right?
Also,
Yep.
I think you wrote the positive negative on.
What?
We talked.
Oh, you told me it's negative and I wrote positive?
Yeah.
I'm sorry.
You corrected this.
I corrected you, but then I wrote what you told me. Okay. Okay, so we already know what the antiderivative is. From 0 to 3 pi over 2. So what is the cosine of 3 pi over 2? minus the cosine of 0
Two.
times 2 would be
Two.
2. So my displacement is -2. What does that mean?
Because you're to the left of the origin. 2 meters left of the origin.
Okay, we ended 2 meters to the left of the origin. Okay. Now let's talk about our distance. Make that sign chart visible here. Our distance, how many integrals will we have?
2.
Okay, we will have 2 integrals. Our first one,
Negative integral from 0 to pi.
we should have the negative integral from 0 to pi, since we have negative velocity. And then, since we have positive velocity from pi to 3 pi over 2, then that can remain positive. So we're going to have -2 cosine of t evaluated from 0 to pi, and then 2 cosine of t evaluated from pi to 3 pi over 2. What's the cosine at pi? Okay, so we're going to have 2 minus cosine of 0. So 2 minus -2. Yeah? I didn't, I know plus cosine at 3 pi over 2 minus cosine of pi is -1, so -2. Right? So we travel a total distance of 6 meters to end up to the left of the origin. Yes, meters straight. Okay. Questions? Okay. Today we have a worksheet, but you get to earn your worksheet. In your notes, I would like you to answer these 3 problems related to this velocity equation. When you have these 3 problems, I would like to see your 3 answers. Really 1 problem, 3 parts. I would like to see your 3 answers, and then I will give you the worksheet.
If we do not earn it, do we have to do it?
Yes. You have until the bell rings. If I haven't seen your answers, then I'll just give you the worksheet.
Okay.
And I'll just give you the worksheet.
Okay,
No.
Caleb.
Just like this.